Edmund Becquerel, a young physicist working in France, first observed and discovered the photovoltaic effect in 1839. The photovoltaic effect is a process that produces voltage or electric current when exposed to light or radiant energy. In 1883, New York inventor Charles Fritts created the first solar cell by coating selenium with a thin layer of gold. Fritts reported that the selenium module produced a current that is continuous, constant, and of considerable force. The cell had a conversion rate of 1 to 2%. Modern-day solar cells work at an efficiency of 15 to 20%. A few years later, in 1888, Edward Weston received 2 patents for solar cells. The same year, Alexander Stoliatov created the first solar cell based on the photoelectric effect. Both cells use the concept that light will heat up the solar cell and cause electrons to be released and currents to flow. Solar panels are made with silicone solar cells, a metal frame, typically aluminum, a glass sheet for casting, a standard 12-volt wire, a bus wire, and plexiglass. Silicone cells are paired with the metal casting and the wiring, which allow the solar cell's electrons to escape and supply usable energy. The 3 different cell structures that silicone come in are monocrystalline, polycrystalline, or amorphous forms. Monocrystalline solar panels are produced from one large silicone block that are produced in silicone wafer formats. To manufacture these, it involves cutting individual wafers of silicone that can be affixed onto a solar panel. Polycrystalline solar cells are also silicone cells, but these are produced by melting multiple silicone crystals together. Many silicon molecules are melted and then refused together into the panels. Amorphous silicone cells create flexible solar panel materials that are often used in thin film solar panels. These cells are non-crystalline and instead are attached to a substrate like glass, plastic, or metal. These solar panels are lean and bendable, unlike the standard panel. Monocrystalline cells are the most efficient solar cell of the 3 types, but they are also more labor-intensive and more expensive to manufacture. Silicone is used in many objects every day, such as construction materials, such as sealants, ceramics, computer chips, glass, and medical devices, such as drug delivery systems or heart pacemakers as tubing. Silicone has an atomic number of 14. It is a nonmetal with conductive properties that give it the ability to convert sunlight into energy. More than 90% of the Earth's crust is composed of silicate minerals. In 1787, Anton Lavoisier suspected that silica might be an oxide of a fundamental chemical element, but had no means to reduce the oxide and isolate the element. After an attempt to isolate silicone in 1808, Sir Humphrey Davy proposed the name silicum for silicone. Silicone was given its current name in 1817 by Scottish chemist Thomas Thomson. Jöns Jacob Borellus is given credit for the discovery of silicone. Silicone, in its more common crystalline form, was not prepared until 31 years after. Silicone is made by reducing quartzite or sand with highly pure coke. The reduction is carried out in an electric air furnace with an excess of silicone oxide to stop silicone carbide from accumulating. This reduction is known as carbothermal reduction of silicone dioxide. There are many applications of silicone in society, such as waterproof sealants in homes, computer chips, liquid crystal displays, or solar panels for sustainable energy. Silicone manufacturing is an $11 billion global industry, with total sales of silicone products in the Americas accounting for $3.1 billion and around 535,000 metric tons. Silicone manufacturing alone directly employs just under 30,000 people across the world. Silicone makes up over 90% of the Earth's crust and is the second most abundant element in the Earth's crust, only surpassed by oxygen.